Okay.
Sir, can you repeat again, sir?
Basically, you have to give the attendance like your class roll number slash your name in the chat box. Okay, for the hand drawing class. And basically, so if it is recorded, we will automatically get that your roll numbers, and that will be cross checked with the Google form that will be circulated in the second half. Basically, okay. So here all of you can give your roll number slash your name. Only that much, nothing else. Someone is writing, sir, can you send the link of the Google Classroom? Google Classroom, you just install the app in your mobile and one code will be required for joining. That code is given in your WhatsApp group. Okay.
So slash or underscore we will have to give, sir.
Someone is writing underscore, I told slash. Okay, not an issue. Those who have written, don't write twice. Okay, so let us start today. Today we will basically discuss about the further problems on your assignment number one. So basically, before going to the problem number 2, 3, 4, 5, what these 2, 3, 4, 5, these problems of your assignment number one is regarding your some specialized engineering curves. Fine, some specialized engineering curves, as I told. Okay, that I told on the very first day. Now thing is that today we will try to finish at least two of those curves. Okay, and rest of the two will be discussed on the next class. Now all of you, I request all of you to join the Google Classroom, because that after completing any assignment we will take the assignments through your Google Classroom only. Okay, through that Google Classroom only. That's why all of you are advised to join within 1 day or 2 day. uh, Within today basically, that will be better. Now before going to that engineering curves, in the last class I have discussed the diagonal scale, right? So in the diagonal scale, one thing I have told you that we have to know, I will discuss on the next class, that is the division of any line into some equal number of parts. Okay, using set square method. So that I told I'll show you in the next class, that I told in the last class. So today let me show you that first. Let me share the screen. Okay, you can see, if you can see my screen, then I am showing you on.
Yes, sir.
Okay, I'm showing you on YouTube, because otherwise it is not possible. There are several videos in YouTube. You can have a look of that, but still it's my duty to show you once, to explain it once. Okay, can you see the screen, the YouTube screen?
Yes, sir.
Okay.
Yes, sir.
Uh,
Yes,
okay. Basically, you may not be able to see the sound. No, not needed. I will explain what he is doing. Basically, you can see one straight line. Okay, here, over here you can see one straight line. So this straight line, say it may be having any length. Okay, so this straight line I have to divide some equal number of parts. It may be 4, it may be 5, it may be 7, it may be 8, right? Say I'm having a 10 centimeter line. Say for example, I'm having a 10 centimeter line. I have to divide that into 10 equal parts. Then it is very easy that each of the part will be of your 1 centimeter each, right? So that thing you can do by your scale. But if I ask you that divide this 10 centimeters straight line into uh, 7 equal parts, then it will be not possible for you. Okay, or your say your 8 equal parts or whatever. So any line, okay, if I want to divide into some equal number of parts, I have to follow the set square method. What we need these two types of set square that you can see. Okay, over here, this one is the 45-45 set square, this one is the 30-60 set square. That is very clear from the included angles of these set squares. Now using these two set squares, how I can divide this straight line into some equal number of parts, very important. Several times you may have to use this process in different types of drawings. Whenever you are having any this type of cases, you have to follow this set square method. Now you see, if I'm having, first you draw the straight line. Okay, then next step is to, from any, say this is point A, this is my point B, this is my initial point, this is my final point of the line. Okay, now first step is to draw a uh, just draw an inclined line. Okay, say in this direction, just on the lower side. Okay, I'm showing you. The first step is, you can see over here, just take, this is my straight line that I have to divide. Next, what I'm doing, I'm drawing a inclined line, any acute angle. Okay, now question may arise, sir, what is this angle? Okay, this inclined line, what is the length? Length, there is no such length, there is some no such rules, but you have to take an inclined line at an acute angle. This angle may be 30 degree, 40 degree, 60 degree, but any acute angle you have to take. Now take this line for a certain distance for your reference. Okay, next you have to take your compass. He will show you. Wait for that. Next, once you have drawn this inclined line, okay, from the initial point, this is the main line, okay, that I have to divide. Now take out your compass and fix any arc length. I repeat, fix any arc length. In this compass, fix any arc length. Okay, for example, say I have to divide it into some equal number of parts. Okay, how many parts? Let me see that how many arcs he is taking on this inclined line. Again, I am repeating the last step, that is, I am taking the compass, I am fixing a small arc. There is no such measurement for that, but that arc should be same. We just, once you are fixing that arc, you are not supposed to change that arc length or that size. So just he have fixed right now, you can just, you have seen that, and then he is taking some arcs on that inclined line. How many arcs? Let me check how many arcs he is taking. All the equal arcs you can see. Okay, whatever the arc length may be small, maybe a bit big, but that will not matter. Obviously it should be a moderate length. Okay, he is taking simultaneously arc, you can see. Okay, 1 2 3, he is counting. Let him finish so that we will understand in how many parts he want to divide. Okay. Okay, now see, let me check. 1 2 3 4 5 6 7 8 9 10. He have taken 10 equal arcs starting from this initial point of the line. He have taken 10 equal arcs on this inclined line. That means what? That means I have to divide this line, this straight line, into 10 equal parts. That means initially what is available to me, I know that in how many parts I have to divide, that I should know. So whatever, say if I am having this line any length, and if I have to divide this line into 7 equal parts, how many equal arcs will be taken over here on that inclined line? How many equal arcs I have to take on this line? If I have to divide this straight line into 7 equal parts, how many equal arcs I have to take over here?
6,
7.
Why
6, sir.
why 6?
6,
7. Why 6? Because here I told that here 10 equal arcs he have taken. Okay, 10 equal arcs he have taken means I have to divide this line into 10 equal parts. Number of equal parts should be equals to number of arcs. Is that clear? Is that clear?
Yes,
yes, sir,
sir.
yes, sir, yes, sir.
Okay, so 10 equal parts I have to divide. That means I have to take 10 equal arcs. Now once I am taking 10 equal arcs, and this is the last arc point, you can see my cursor, this is the last arc point as per his drawing. And next step should be join this last arc point to the last point of the line. This is the last point of the line, nowhere else. Take your scale, join this last point of the line, that means this is, and last arc point, this is the last arc point over here for this case. So I think you will join now. Let us see. You can see 10 equal arcs he have taken to divide this straight line into 10 equal parts. Now he will be joining this. Now he's showing how he can place the set square, that we should come later. First you have to join. Yes, he is joining, you see. Yes, this is the part, last arc point to the last point of the line. This thing you can join by your scale also. Okay, doesn't matter. Last arc point to the last point of the line.
Sir, please make the video full, sir. Mm,
Okay.
The student is asking.
Okay.
See, the sum of the student is entering into the name of Tanistor S13S. if I found that it is not official name, I won't allow entry of such type of a student.
Okay, now see here, this is the last arc point and this is the last point of the line. First you have to join that, okay, by a scale. Okay, so this is the first line. Okay, just you can see this is the first line. Okay, this is the first line, that is my first task. Next, you see, next I have to place these two set squares in such a fashion that I can draw some parallel lines with this line that I have just drawn. Okay, so how can I draw parallel lines with the help of set squares? Now I have to align one of the set square with this line. Let me check here how he have done, otherwise I'll show you in some different video. Hmm. Okay, see over here. First what you have done, first you have drawn this last line. Okay, this last line. First you have drawn this last line. Okay, then next task is to draw parallel lines. But how can I draw those parallel lines on each of these arc points that I have taken on the inclined line? I have to align one of the set square, say this 30-60 degree, this one is a 30-60 set square. I have to align this set square with this inclined line that I have drawn. Okay, I have to align this set square with this inclined line that I have drawn. Okay, next I have to place another set square, that means another one, I should have another one at the bottom. Okay, here here placed. Make this set square fixed, make this set square fixed, this one. Okay, this one will move, this one is basically slide. Now you see how it is sliding and which one is fixed. You just see the video, you will be understand. You see this one, this one, this set square is fixed, it is not moving, only this is sliding over that. Okay, so that I am getting parallel lines or not. I am getting parallel lines where they are drawing at each of the arc points. At each of the arc points. Now, by using your left hand, this set square should be fixed. It should not be moved. If it is moved, then you will be not getting the parallel lines. Okay. So once he will finish, you see the for the last arc point he is drawing now. Now you just count that. Okay. Now you just count the main straight line has been divided in how many parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that clear? In this way, you have to divide any straight line into some equal number of parts with the help of set square method. I am repeating the whole thing by steps. First step, take the straight line. Listen carefully. First step, take the straight line. Second step, from the initial point, say from this point, or you can draw this inclined line from this point also, that is up to you. From any of the end point, draw an inclined line with an acute angle with the straight line. Say this is the second step. Third step, you have to know that how many parts you have to divide into this straight line, into how many parts I have to divide. Say for example 10 in this case. Then you have to take out your compass. Okay, using that compass you have to fix a arc, small arc. That arc, there is no such length of that arc, there is no fixed length. You can take any arc, but that arc length should not be changed. If you change the arc length, these parts will be not equal, unequal parts you will get. Once you are fixing that arc length, starting from this point, cut some arc points on the where, on the inclined line, not on the main line, on the inclined line. So 10 equal arcs he have taken. Okay, up to this clear? Up to this clear or not?
Yes, sir.
Next
Yes,
step
sir.
is,
Yes, sir.
Yes, sir.
okay, next step is, try to listen carefully. Next step is, say this is my last arc point. Here I have to divide into 10 equal parts, that's why 10th point is my 10th arc point is my last arc point. If I have to divide into 7 equal parts, obviously I will not take 7 arcs. Obviously I will not take 10 arcs, I will take 7 arcs. Then that 7th arc point will be my last arc point. So here my 10th point is my 10th arc point is my last point, arc point. So from that point I am joining this end point of the line, last point of the line, by my scale. Okay, next I am taking two set squares that I am having. Okay, again I am showing that part, please see carefully, and I am explaining parallelly also. You see, first you join, you have to align, first you have to draw this line, and you are aligning this set square with the end line, and you are placing another one at the bottom, so that this will be fixed and this will be slided over that. Okay, so you see at each of the arc point I am drawing some lines up to the main straight line, so that my 30-60 set square, you can see that is sliding over this 45-45 set square, which is fixed by me. No one will help you to do this. You have to do this by just using your two hands. Okay, so at each of the arc points you are drawing some parallel lines, and in this way you are getting that 10 equal parts on the main straight line. Okay, so this is the process, this is the method to divide any straight line into some equal number of parts using set square method. Okay, I think it is clear. May I proceed?
Excuse me, sir.
Yes.
Sir, how can we understand that how much we have to slide about 30-60 square?
How much you have to slide? Is that your
Yes,
question?
sir.
How much you have to slide means just by sliding you have to reach, you see, from this one arc point to another arc point. Then you have to reach from this arc point to this arc point. When I have drawn the lines from all the arc points, then my work is done. Understood? By
Yes,
sliding,
sir.
what I am doing, I am drawing these parallel lines, these lines. So just when I have reached this last point, my work is done. I don't need to slide more. Understood?
Yes, sir.
Okay. So this method will be used several times in the diagonal scale also you have to use, and in some later parts also you may have to use. So that's why I have given some time. I have spent some time over here for using this set square method. This is very important to divide. There are several methods. You see, if you search, there are several methods to divide this line, but you have to know the use of the set squares. That's why you have to follow this one. There is no other, if you use in your assignments any other method of dividing any straight line, that will be not granted. So you have to follow this method, set square. You have to learn how to use the set squares. Okay, so that is the method you have to follow. Now let me back to the assignment one. Okay, I think you can see the assignment one. Okay, this assignment number one, problem number one was discussed in the last class. Similar problem I have discussed in the last class, that is regarding your diagonal scale. Second one, okay, second problem is basically second, third, fourth, fifth, these four problems are left. This second problem is regarding an engineering curve that is known as your cycloid. Okay,
Excuse me,
CYCLIOD. Yes.
what is the full form of RF?
RF, I have discussed in the last class, still I am repeating. RF full form is representative factor. Okay,
Okay.
representative factor. Okay, if you see my last class, if you, those who have attended, that is my representative factor. That is the first step of drawing any scale. Okay, then I have to calculate the length of scale, then I have to go to the construction of the scale. Okay, so this problem number two is regarding the curve cycloid. Let me read the problem once, then I'm going to the particular topic, that what is cycloid and all. A circular wheel of diameter 35 millimeter, that means a circle. Say I'm having a wheel, circular wheel having diameter of 35 millimeter, rolls on a straight line, on a straight path. Okay, that path is my straight, that is given. Rolls on a straight line on the ground without slipping. Okay, that is not slipping. Full stop. A point A lies on the rim of the wheel. That means I'm having a point on the periphery of this circular wheel. Okay, that is at any point I'm having a point that is on the periphery of this circular wheel, on the rim of the wheel. Draw the locus of a point A, that means at any point I have taken locus of that point A for one revolution of the wheel. That means my wheel is rotating, and when my wheel is rotating, my obviously my point A is also changing the position, isn't it? I'm repeating my question. When my wheel is rotating, if I'm fixing any point on the periphery of the wheel, then the position of that point is also changing with the rotation of the wheel or not?
Yes, sir.
Okay,
Yes, sir.
so that change in position of that particular point I have to track. Okay, so draw the locus. In this problem, nowhere it is written draw a cycloid curve. If you see the problem, nowhere it is written the name of the curve. You have to decide. Reading the problem, there are different cases. Different cases you will get different types of curves. Here nowhere it is written draw a cycloid curve. You have to understand if this is the case. What is the case? Case means I'm having a circle basically, and that circle is uh, rolling. That circle is rolling without slipping on a straight path or on a straight line. Okay, if that is the case, and if I am having a point on the periphery of the circle, for one single revolution I have to track. If I track that point, okay, when it is rolling, when my circle is rolling, okay, so the location, that means the trajectory of that particular point for one full revolution of that particular circle is known as what type of curve? That is known as your cycloid curve. Okay, so draw the locus of the point means that locus of the point means I will get a curve. If I trace that locus, I will get a curve. That curve is known as your cycloid curve. Then after drawing the curve, draw the tangent or normal at a point P on the curve. That is the last thing that I will show you. After drawing the curve, I have to fix any point on the curve, and I have to draw tangent to the curve and normal to the curve. That is the last part. But first I have to understand how to draw this. What is the case? Have you understood the problem? Have you understood the problem?
Yes, sir.
So let me see now how it will look like. Okay. So you see here also it is written. You see only the cycloid, this part. Uh, It is a locus of a point on the periphery of a circle which rolls on a straight line path. What is a cycloid? Very often it is asked in the Viva. What is a cycloid? It is a locus of a point on the periphery of a circle which rolls on a straight line path. Okay.
Sir, what is the periphery?
Periphery means that just the boundary. Basically the boundary. The
You mean
boundary of
perimeter?
any wheel means
Perimeter.
yeah. Yes.
You mean
Yes,
perimeter?
perimeter. Yes, yes. If you want to just measure, that is a perimeter. But I'm
Okay.
not going to the mathematical length of that or the amount of the perimeter. Just periphery means that circle, basically. Okay, the boundary. Okay, that means whatever the point I'm taking, that should not be on the inside. That means inside the circle. That should be on the boundary of the circle, I should say. Understood? Understood?
Yes, sir.
Okay. So
Yes, sir.
so let me show that a similar problems how to draw those cycloid and all, so that it will be more clear. I think there are different types of engineering curves, but we will concentrate. Yeah, this is the problem of cycloid. Let me give the slideshow. Okay, cycloid. So what is the definition? So definition, that means I'm having just this cycloid is a curve, special type of engineering curve. How I can get this? It is basically the locus of a point on the periphery of a circle which rolls on a straight line without slipping. So that is a simple definition of a cycloid. So read the problem. Similar type of problem we are having. Draw locus of a point on the periphery of a circle which rolls on the straight line path. Take circle diameter 50 millimeter. Here it is given 50 millimeter. In your problem, that was your 35 millimeter, I think. So that change in dimension may be there. So how to draw? How to draw this figure? That means this cycloid. Steps are written over here, but still try to listen my words. Okay, I will try to explain it very easily for your understanding. Okay. First step should be to draw the circle. First step should be to draw the circle, taking the dimension. What is the dimension? Take your compass only. Take the diameter. Here the diameter is my 50 millimeter. That means my radius should be my 25 millimeter. Okay, 25 millimeter means 2.5 centimeter. Take that much in your compass and draw this circle. That is the first part. After drawing the circle, this is the bottommost. This point it is touching the ground. So here I have to draw a straight line on which it will roll. Basically, you can see the direction also. Say I am considering that this circle or this wheel is rotating clockwise direction, in the clockwise direction, that I am considering. You can consider in the anti-clockwise direction also, you will get the same result. Okay, there will be no change in result. So I am having a circle or circular wheel and I am having a straight line path. Now what is the length of this straight line that you will draw? Just touching this bottommost point. So for that means how you will get this point? Basically, if you draw these two lines, you will get this point. Basically, if you divide this circle into four equal parts, if you have seen the one vertical line and one horizontal line through the center, I repeat, one vertical line and one horizontal line through the center, then you will get this bottommost point at which it will be just touching the ground. I need that point. Okay, so here that is the point, and I have drawn a line. Okay, now this line, if you want to draw by only your scale, this line may be tilted something downwards, or it may create some angle. It may be somewhere over here, it may be somewhere over here. So that's why use your roll and draw that instrument to get some perfect horizontal line. Okay, that means you just align your roll and draw with this horizontal line. How to draw parallel line with the help of roll and draw? You just align the roll and draw scale with this horizontal line, and you just pull it just downwards and reach this point. While you are reaching, and if you draw using that scale here, those two lines will be automatically parallel. Okay, is that clear how to draw these parallel lines?
Yes, sir.
Yes, sir.
Yes, sir.
How many of you have bought those instruments? Who have not bought, just tell me. Instruments I told on the very
Sir,
first
please
class.
repeat. Sir, please repeat how to.
Yes, I'm repeating, but have you bought the instruments
Yes,
that
sir.
I have told?
I bought it. Yes, sir.
Okay,
Sir,
so if you are
I have bought everything except the roll and draw, which is not available in the shop now.
no, shop, it may not be available, but I think someone was talking about in Flipkart or your Amazon, it is at 130 or 140 rupees. It is costing.
Okay, sir. Then I will book it
You
online.
just search online once. Okay, I think you will get. I can't remember on which section someone told me, sir, it is available in 135 rupees. So
Okay,
please
sir.
check it.
Okay, sir.
Now I'm again explaining that how to draw these parallel lines. I think these two lines you can draw because that is very easy. If you are having a scale, and if you are having this center point, you can draw this vertical line and this horizontal line. Now my task is to draw this straight path, this one, okay, which is touching the circle. How to draw? That means that line should be parallel to this horizontal line. Okay, so basically, firstly, if you are having a your roll and draw, that roll and draw is having a scale. Okay, so that scale you just align, but that means you just align the roll and draw with this horizontal line first. Once you are aligning, then at that condition you just pull, you just pull that roll and draw downwards. After aligning, just pull down the roll and draw downwards. When you are pulling down it, then at some point you will reach this point or not? Answer me. When you are
Yes,
pulling
sir.
down, you will reach this point at some moment.
Yes, sir.
So at that position you stop and you draw a line, just with the help of same scale that you are having in your roll and draw. So
Okay.
then you will find the gap between, say, at this position and gap between this position is same. That means these two lines are parallel. Automatically you may get by your using drafter also, mini drafter also, or you can get it by, as you are not having drafter at this point of time, you can draw the same thing by roll and draw. Okay, so this is the step. Just you align first with which you have to make parallel, then you just pull down to the required point and you draw the line. So that will give you the parallel line. Okay, so now my question to you is that as per my problem, uh, this circle is rotating for one full revolution. I will track any point, say this point, say okay, that part I'm coming, but say for example, the point that I was talking about in the last slide, point A, I can take any point on the periphery, on the boundary of this circle. Say I'm taking this point, the point that at which my circle is touching the ground. I am taking this point. So if this circle rotates, and that means for one full revolution, if I want to track, that means if this circle rotates, obviously this point just will move up. If it rolls more, again that point will move up. Okay, so that is basically the how this point, that means when it rolls clockwise direction, just you have to think physically. If it rolls the point, if I'm fixing any point, say this is the point, it will change its position gradually. Okay, so for one full revolution, what is the that locus that I have to track? Now for one full revolution, you tell me how much the circle will move on the straight line. If the circle diameter is d, if the circle diameter is d, then for one full revolution of this circle, how much straight line distance it will move on this line? What is that length will be?
Sir,
What
the
that length will be? Yes,
perimeter of the circle,
yes. What is that? How much length?
Pi
2 pi
d.
d
Pi d or 2
into
pi
pi
r,
d by
whatever
2.
you say, right? That is my
Pi.
pi d. So I am interested. That means how much the length? What is what will be the length of this straight line? That will be basically from this point. Just remember, from this point, I have to take pi d distance. Okay. So that is basically my point of concern. That is basically this circle will move up to that. It may move beyond that also, but my point of concern is up to that for one full revolution. Okay, I'm showing that pi d part, but before that I have to divide this circle into some more number of parts. How many parts? Standard is your 8 equal parts. You can see this circle is divided into 8 equal parts. How I can do that? Earlier I have shown already, it was divided into 4 equal parts. Now easily you can divide. You see, if this is one part, this is my 90 degree, from the center point you just draw a 45-degree line and that extend on the other side, so that, and the same thing for the second part also, you draw a 45-degree line over here and extend that on the other side, so that it will be divided into 8 equal parts or not, this circle.
Yes,
Is it
sir.
clear? It's very easy.
Yes, sir.
Firstly, you have divided by this horizontal and vertical line 4 equal parts. Then each of the part, if I want to divide again, just you draw a 45-degree line. Okay, over here, this angle is your 45-degree, and you extend that line by your scale on the other side, so that it will cut somewhere over here at the circle. Okay, the boundary. So naming, now naming is important. Okay, this is the point P I am taking, and if you see the naming 1 2 3 4 5 6 7, and this P point is nothing but the 8th point. This P point, basically the locus of this P point I will track while my circle will move. Okay, so now the naming is very important. Why? As my circle is moving clockwise, my naming should be also clockwise direction. If I am considering my circle is moving clockwise direction, if I am naming the circle, this division of the circle in anti-clockwise direction, that will be basically wrong. Wrong means it will make confusion in the latter steps. So that's why my circle is moving clockwise and I have to take this clockwise namings also. Okay, this P point is the 8th point. Now draw from this, and this C point is the center. Okay, center point of this circle, and from this C point I will draw again a line. That means this central line, basically I will extend up to how much distance? This is that pi d. Okay, this pi d distance you have to take.
50 millimeter.
Sorry,
D means 50 millimeter.
d means here 50 millimeter, the circle diameter.
So
Okay,
pi d, we have to calculate the pi d, and
yes,
after
you have to
that.
calculate the pi d. Here it is written pi d. You have to just, if d is given, you have to calculate the pi d. You have to show that calculation on the drawing sheet also.
Okay,
And
sir.
here that much of amount you have to take.
From
This
the
P,
center of the circle we have
yes,
to
from the
draw it.
center of the circle to the end, or the same thing from the P to the end. End means
Okay, sir. Okay.
on this straight line. The same thing,
Okay.
same length you will get. Okay. So now you see, firstly my suggestion is you can take this from point P, you take the pi d distance. Okay, say somewhere over here it will be there, and draw a line from the C also. This line is your central line. Okay, so this is the length pi d that we have marked. Now see, you will be seeing some divisions. How many divisions on the central line? You can see some divisions. Yes, now see, from C to the last point, how many parts we have divided? 1 2 3 4 5 6 7 and 8. 8 equal parts we have divided, and we have named those points. This is the C point, next point is my C1, next point is my C2, and so on, and it will run up to C8. Why we have divided into 8 equal parts this central line? Any idea from your side? why we have divided this central line, means from the C to the pi d distance. Why this central line we have divided into exactly 8 equal parts? Why? Any idea?
So can you repeat?
I'm repeating the question. You can see here that from the center point C up to the pi d distance, this is the pi d distance up to the end, this length we have divided into 8 equal parts, that you can see. Okay, using the set square method, you have to divide 8 equal parts we
Sir,
have divided. Why? Why means why 8? My
the,
question is why 8?
the circle.
Yes, that is very common sense that someone have answered, that I have divided this circle into 8 equal parts. That is the reason why I have divided this from the point C to the end, that distance, into 8 equal parts. That means this circle may be also divided into 12 equal parts also. More number of parts here you divide in this circle, more number of locus point you will get for tracking the your trajectory. More number of locus points you will get for the trajectory, more accurate will be your curve. Very simple. This is the relation. Now it is a standard value that you are dividing into 8 equal parts, but if anyone wants to divide this circle into 12 equal parts, you can do, there is no problem. But then whatever the length you are having from C to the end, that length you have to divide into 12 equal parts. Exactly. Here we have divided the circle into 8 equal parts. That's why we have divided from the C to the end this line. Which method? By the set square method that I have discussed few minutes back. Using the same method, you have to divide this line. Okay, or another way you can do, you can divide this from P to the end line on this bottom line, and you can take vertical lines up to the central line, so that you will get these C points. That is up to you. Okay, you can directly divide this central line from C to the end, or you can divide this from P to the pi d length, that length, okay, here into 8 equal parts, and whatever the divisions you have got over here, equal divisions, take a vertical line up to this central line, you will get the similar points. Is that clear up to this, or any doubt?
Yes, sir.
Yes,
Clear.
sir.
Now I'll move to the last step of the drawing.
Okay,
last
sir.
last
Yes,
step is
sir,
what?
we-
Yes.
Sir, we
Yes.
have to point the C dots in the both lines.
No, C stands for central line. Okay, C stands for
Okay.
center, and these points obviously should lie
Oh,
on the central line. Okay, so that's why
only
it
on
is
the
written
central line we
C1.
have to draw it.
Yes, C1, C2, C3. My
Okay, sir.
target is this one, to divide this central line.
Okay,
Now,
sir.
what I told, if you are thinking that here it is just a bit difficult, that taking an inclined line from the C, then use the set square method, you can divide at the bottom also this line, then you can take some vertical lines, okay, to get these points, C points. Clear my view?
Yes, sir. Yes, sir. Clear, sir.
Yes,
Okay.
sir.
So you have choices as per your convenience. You can proceed by my but my main target is to divide this central line and to get this C1, C2, C3 like these points up to C8, because I have divided into 8 equal parts. That's why it will run up to C8. Now the last step is uh, no, this is just last before step. Basically, you have to draw this type of horizontal lines. That means just join this point 1 and 7 by your scale and extend, okay, like this up to this pi d distance. Similarly, 2 and 6 has been already joined, that is nothing but the central line. Similarly, you join 3, 5, 3 point and 5 point and extend, okay, up to the pi d length. And from this point 4 also you draw a parallel line to these lines. Use your again the your roll and draw instrument to draw the parallel lines. Okay, so this from this 3, 5 line, it is very easy to, you don't use roll and draw, because you just join by your scale 3 to 5 and you extend this line up to the pi d. For this point, from this point 4, while you will draw, you may need the roll and draw to get some parallel lines. Okay, now once you will get this points, now you have to take out your compass. Okay, you have to take out your compass. I repeat, you have to take out your compass. Taking out your compass, first you take CP length in your compass. What is the CP? From the center to this point P. That means it is nothing but the What? It is nothing but CP is nothing but the radius, right?
Yes, sir.
CP is nothing but the radius of the circle. You take the radius of the circle. Okay. That should be fixed in your compass. Fix this much of length, CP. That is the radius of the circle. Next, you place at C1. You place that your one leg of the compass at C1 and cut the one line. I repeat, place the one leg of compass at this C1 point and cut the one line. One line means one line and 7 line is same. Okay, so cut this line so that you will get a point somewhere over here. You can see this one. I will mark this point later also. Just see my cursor. Just exactly at this point, this will be cut. That means placing the compass at C1, you are cutting 1 7 line so that you are getting one point over here. Next step, same. The arc length should not be changed. That should be CP. Place my compass at C2 now. Cut the 2 line. C2, C suffix 2 corresponds to 2. 2 line means 2 and 6 line is same. So that should be cut horizontally on this central line. Okay. There should be a point over here. Okay, I will show that point exactly. Just please bear with me for a few minutes. Next, similarly, CP will be my length. Okay, that is not changing in my compass. I am placing at C3. Which line I should cut? Third line, right? Third line means 3 5 line. 3 line and 5 line is same. That means this horizontal line. You can see I am cutting over here. Okay. Fourth, C4. From the C4, which line I should cut? You tell me. From the point C4. Fourth line. Fourth line means this is the topmost line. That means it will touch. It will just touch the topmost line. Okay. Whatever the arc you are cutting, it will just touch the topmost line. Here you can check your drawing. You have made any mistake or not. If you have taken all the dimensions properly, then here this arc will just touch the topmost line. Okay. Next you tell me. Anyone from your side, you tell me.
Taking the CP length from the C5, the compass will cut the 3 5 line.
From the, yes, CP will be fixed. CP is fixed, that you know. From the C5.
C5 point.
Now
We have to
C5, I will cut the 5 line. 5 means 3 5 line.
3 5 line.
But you see, I can cut on this side, left side, or I can cut on the right side. Which side I can cut that length? Which side I should cut? Left side means that length.
Right side.
Right side. Someone is telling right side. Why right side? That means if I cut right side from the C5 somewhere here, that means exactly like this. It will be like this, right? But taking that length, I may cut on this side also. Why I am not cutting on the left? Why I am cutting on the right?
The right in the 5 is placed right side of the circle.
Try to think physically always. What is happening? What are these points? Basically, this point P is moving up while it is rolling. While my circle is rolling, what these points are? This point or this point or this point, right? So while it is rolling clockwise, obviously my P point will shift towards right, not to the left. Isn't it? Is this point clear to you? While this circle is rolling clockwise direction and I am trying to track the point P, okay? That means if its circle rolls on clockwise direction, obviously my point will shift towards right or left. Obviously to the right.
Yes, sir.
Yes,
So
sir.
that is the reason. So that is the reason why we are cutting on the right. From C5 we are cutting on the right. Okay. And from C3.
Sir, I could not understand this. Please repeat again.
Okay, you first listen to me that why we are locating this point. What are these points basically? This point, okay, this point and so on. Let me just complete, then I am again explaining you. Complete means this cutting part. From C6 I will cut on the 2 6 line. Obviously on the 2 6 line I will cut towards right. Okay. From C7 I will cut 7 line means 1 7 line somewhere over here, and from C8 obviously I will cut over here. That means that will touch the ground only. Now I am showing you the points. Now it will be clear to you. You just see the points. Now try to understand. What are these points? Basically, this is the movement of this point P while it is rolling. While my circle is rolling, my point P is going upwards, going upwards, going upwards, and at some time it is reaching the maximum height. Okay. Then again, if it rolls, if the circle rolls, now my point P will go downwards. Okay. So that's why now my question was from the C5, I will cut y to the right, okay, not to the left, because after this point, if my circle rolls more, if my circle rolls more, my point P, that is now at this point, okay, now at this position, that will move towards right or left. Someone please respond, because who were
Yes.
asking,
Yes,
who
sir.
was asking, so that point should move again towards right, because my circle is
Yes,
going
sir.
clockwise,
Rolling clockwise.
rolling clockwise direction. So
Yes, sir.
that's why I have cut from the C5 to the right. From the C6, this is the point, because that 2 6 line on the horizontal line, that means this line, the central line. That's why I have cut over here. This is the corresponding point. From the C7, it will cut 1 7 line, and from the C8 again it will touch, because this is for one full revolution. Okay, that means P point will start from the ground and again it will meet at the ground. That is possible only for one full revolution. Now if I join these points, okay, you can name it like P1, P2, P3, P4, P5, P6, P7 and P8. What are these points? These are nothing but the locus points. Okay, while my circle is rolling, these points are nothing but my locus points of that particular point P. Okay, now if I join these points, I will get a curve something like this. This curve, the black highlighted curve, this curve is known as your cycloid. Now tell me on which step you are having doubt. My drawing is complete. If you are having at any step any doubt, you can ask me. Now question is, sir, how I will join these points, by freehand or by which instrument? Now that answer is, while you are having this type of points and you have to join, you are not supposed to join by freehand. You have to use the instrument French curve that I have told you to buy. So how to draw by French curve? Try to understand the rule for joining these points. For any curvature, while you are having any curvature, from this point you are starting. My curve is starting from this point. So take the first 3 points. I repeat, take first 3 points. First point, that means P, P1 and P2. I am taking these 3 points. Align the face of the French curve. You have to check. That means which face is aligning, that you have to check. There is no particular rule that for cycloid this French curve will be used, or for any other curve that French curve will be used. There is no such rule. You have to check. Align first 3 points, but join first 2 points. Leave the last one. Align the face of the French curve with the first 3 points, but join by your pencil first 2 points. Okay, this part only you join. Leave the last point. Next step will be align next 3 points. Next 3 point means P1, P2 and P3. Align next 3 points and join the 2 points. Which 2 points I have to join now? P1 and P2. These are to the first points now, because now I am aligning P2, P3, P1, P2 and P3. These 3 points I am aligning on the face of the French curve. I have to check that your which face is appropriate for your alignment. If it is aligned with these 3 points, then I have to join P1 to P2 and so on. Okay, and the same process you have to join. Align 3 points, join the first 2 points. Align 3 points, join the first 2 points. Okay, so that should be the process. By using the French curve, you have to draw. Basically these things is very difficult to make you understand virtually, but still I am telling you the process. You listen to me very carefully. If you forget, that's why I will share this recording in your Google Classroom, so that you can listen and according to that you can do. And where you will use freehand, if some points are not coming in the face of the French curve. That means, say this, you can see here P3, P4 and P5. These 3 points are far apart, you can see, and these 3 points may not come, may come, I don't know, but may not come. Say it is not coming on the face of the French curve, then only you can join by your free hand smoothly. But those points where it is coming on the face of the French curve, you have to use the French curve for the joining purpose. Is that clear?
Yes,
Yes,
sir.
sir.
Now you have to practice once. Okay,
Yes,
then
sir.
only when we will practice, you may face some doubt, then you can share with me on the next class, while you have to, why you just listen to this recording, and you just draw, okay, at least once in your home. You solve the problem number 2. Okay, so then you will be, if you are facing some problem, I will obviously help you out.
Sir,
Now,
is the recording in the Google Classroom?
recording means, this lecture is being recorded right now. I will share it within the evening. Okay,
Okay,
then
sir.
evening I'll share it.
Okay, sir.
Now this pi d, which dimensioning you have to do over here, it is not finished. Finished means I have to give the dimensioning, the required dimensioning for the drawing. This pi d, here it is written pi d, but you will write the value, exact value that you are calculating for the pi d, and you know how to give the dimension, that I will not repeat, that I have discussed in the last class. So from the point P up to the end, that is the pi d distance. Another thing you have to keep that is not given over here, I think, the radius. Okay, the radius of the circle or the diameter of the circle. I have shown you in the last class how to give the diameter, how to show the radius. So that thing you have to show for this circle. So the dimension of the circle and pi d distance. These two things are the dimensions. Is that clear?
Yes, sir.
So that
Yes,
much
sir.
Yes,
for
sir.
the cycloid
Sir,
as of now.
sir,
Yes, any doubt?
can you show the PPT of the required instrument again?
PPT of the required instrument. I have told, if anyone, okay, I will write in the Google Classroom. Okay, I think that will be better. The instruments required as of now, I will write in the Google Classroom. Okay, I will write in the,
Sir, hello,
yes.
sir.
Mhm.
Sir, we have to do these drawings in the sketchbook.
Sketchbook. You have to do this in the sketchbook.
Okay, sir.
Follow the question number 2 of the assignment number 1. Take those dimensions and try to draw it. Okay. It is already 3:07. I am having 3 more minutes.
Sir,
Yes.
sir, I have bought A3 sketchbook. Is it okay?
A3. Okay, fine. Not an issue. Fine, it's fine. I think A3 is
Yes,
a,
Okay,
sir.
sir.
whatever the size you are having, try to draw on that. Not an issue.
Sir,
Okay.
A1 it's okay.
A1 sheet. A1 sheet is very good, but how we will place the A1 sheet? A1 is means very large drawing sheet. If you are having a drawing board in your home, then you can use that. I have no problem. Understood? But A1 is very
Sir.
large sheet.
So will the
Okay,
last
sir.
class recording be available in the
Last class recording, I have recorded in another section. I can share with you. If you are having not a problem, I can share.
Sir,
Okay, sir. Thank you,
Okay.
sir.
Sir?
Bol.
actually, I have bought 15 inch by 10 inch drawing book. Is it allowed?
15 inch by 10 inch, হ্যাঁ ঠিক আছে, কর না, not an issue. অসুবিধা নেই, আমার কাজটা নিয়ে কথা,
Sir,
ঠিক আছে?
what are the numbers of the French curve?
I think if you
5,
buy
7.
3 French curves, they will give the number. If you ask, French curve number 5, 6 and 7. Most
Yes, sir.
5, 6, 7. Now please allow me 2 minutes to show you the tangent and normal to this curve, because if you see the problem, that this is the black, this one should be the curve, cycloid curve. And one more thing regarding use of pencil, only the cycloid curve, this deep one, that should be drawn by which pencil? HB pencil. Okay, other parts you can see that is light. All those things are supporting drawing. Okay, so only this cycloid should be highlighted by your HB pencil. Other parts should be light by your H or 2H pencil. So this is the use of pencil that you have to maintain. And regarding the tangent and normal, please give me 1 minute. I'm saying it is available with me right now or not. Amrit, I think it is there, right?
Yes, sir. It's available.
Yeah, this one.
Yes, sir.
Okay, please see. Please see, it will take 2 minutes. Then you will join the AutoCAD link. Please stay back for 2 minutes because this will be required. Cycloid, method of drawing. Okay, tangent and normal. This part is left only. Okay, so I am directly showing you up to this, because up to this it is clear to you. Okay, here this is the cycloid that I have got. Now I have to take any point on this, on the periphery of this curve. Okay, just forget about this circle right now. I am having the curve, deep dark curve. I am taking a point, any point. Say over here I am taking a point. You can take at any position, that is up to you. Take any point, say that point is Q. At this point I have to draw tangent and I have to draw normal to this curve. I repeat, tangent to the curve and normal to the curve. So how to draw that? Again, take your compass. Take your compass, take this length, that means the radius of this circle, CP. Again, take that length, CP. CP is very important dimension. So take this from the center to this point P, that means take the radius of this circle. Taking that radius, place one leg of the compass at the point Q and cut CP length on the central line. Cut CP length on the central line. Can you see this CP? Central line means
Yes,
this
sir.
on which this C1, C2, C3, C4 are there. You will get a point, intersection point. From that point, you drop down a line up to the horizontal line, base horizontal line. That means the straight path on which my circle is rolling. Okay. So while you are drawing this vertical line, you are dropping down, it will intersect at some point, this straight line. That point is nothing but N. Name it as N. You can name by your any means, but here let us assume that point is N. Now join that from point N to this Q and extend. That line is nothing but the normal to this curve. I repeat, whatever the point I have got over here, point N, from that point just use your scale, join the point Q and extend. That is the normal to this curve. Once you are getting normal, how to draw the tangent? Tangent and normal makes how much angle?
90 degree.
90 degree.
90
So
degree.
90 degree, you know that. So at this point, at the same point Q, I need the tangent. So at the same point Q, I have to draw a 90 degree angle so that I will get the tangent as well as the normal.
Okay.
Very easy. I am repeating last time. Take any point Q, take your compass, take the length CP. Listen carefully. Take the length CP,
CP.
place at that arbitrary point that you have taken Q.
Yeah.
Cut that on the central line. You will get an intersection point over here. Just by using your scale or your roll and draw, by whatever means, drop down a perfect vertical line up to the base line. Okay, base path that will intersect the base path at some point N. Join that point N with Q and extend. That will give you the normal to this cycloid curve, and just after that you draw 90 degree at this point Q to the normal. That will give you the tangent. I think I'm clear enough.
Yes, sir.
Okay. So thank you very much for attending this class. I was targeting 2 curves today, but it is very time has been lost. So it's not an issue. We will finish 2 more curves on the next class. Okay. But before that, try to practice. I have to go slow initially because the things are new to you. So that's why I have not discussed 2 curves over here. So I have discussed cycloid curve today along with the tangent or normal. Practice once in your sketchbook. Whatever the problems you are facing, tell me on the next class. Is that clear?
Yes, sir. It's clear.
Okay. So thank you for attending.
Thank you, sir.
Okay.
Thank you,
Welcome.
sir.
Thank you.
Welcome. I'll
Thank you,
share
everybody.
this recording in your Google Classroom. Okay.
Okay, sir.
And regarding your AutoCAD class, you now. Sorry. What you told? Hello. Okay. So attendance you have already written over here, and one Google form will be also I will circulate on the during the AutoCAD class. There also you have to give. Okay. So I will cross check both the attendance. If someone is not common in both the classes, he or she will not get attendance. Make that clear. Okay. So thank you for attending. See you in the next class.
Thank you, sir. Have a nice day.
Thank you. Join to the AutoCAD class, all of you.
Sir, I have a question, sir.
বল
বলছি স্যার A1 যে পেপারটা হবে ওটা মানে মানে যে ইয়েটা হবে না, ফুটোটা হবে, ওইটা কোন দিকে হবে, আড়াআড়ি না লম্বা দিকে?
কি বললি বুঝতেই পারলাম না আমি। A1 সিট তো আমি ইউজই করতে বলছি না এখন। A1 সিট ইউজ করতে পারবি তোর
না,
বাড়িতে?
এখন না স্যার। না না, ওটা বলছি না। A1 শীট মানে আমার একটা বন্ধু, ও
হুম।
কিনেছে,
আচ্ছা।
ঠিক আছে? তো A1 শীট ও কিনেছে, তো কিনে ও বলছে যে ইয়ে মানে লম্বার দিকে ফুটোটা নেবে, মানে সামনের দিকে না আড়াআড়ি ভাবে যে সাইডে ফুটো আছে ওইটা নেবে।
ল্যান্ডস্কেপই তো হয় ওগুলো, ল্যান্ডস্কেপ মোডে যেটা আছে ধরো, মানে সাইডে
ল্যান্ডস্কেপ।
বেটার। হ্যাঁ ল্যান্ডস্কেপ, ঠিক আছে।
ঠিক আছে স্যার।
পোর্ট্রেটে যেন না হয়, ঠিক আছে।
ঠিক আছে স্যার।
ওকে, থ্যাংক ইউ।